The subject of this exercise is stresses due to bending. The structural steel wide flange beam shown is a W10 by 60 section. The allowable flexural stress is 28 kilopascals square inch. Calculate the maximum moments Mz and Ny that can be applied. The maximum normal stress of a section subjected to pure bending happens at the fibers that are farthest from the neutral axis or flexural axis. When the section is symmetric about this axis, as is the case of the W shapes, the magnitude of the maximum compression stress is equal to the magnitude of the maximum tension stress. Furthermore, if the allowable stress of the material is the same in tension and compression, only the absolute value of the maximum stress is of interest. First, the elastic section modulus about each axis must be determined. This is defined as the moment of inertia about the bending axis divided by the perpendicular distance to the farthest fiber of the section. For example, in bending about the z-axis, the elastic section modulus is equal to the moment of inertia about the z-axis, which is the neutral axis or bending axis, divided by the farthest fiber in the y direction, y max. The elastic section modulus about the y-axis is computed in a similar fashion. However, the section properties of standard rolled structural steel shapes, such as the wide flange sections, including the elastic section modulus, are already given in tables for practical use. That is how the elastic section modulus were obtained in this exercise. Having determined all the required variables, the next step is to compute the maximum moments using the equation that describes the normal stress distribution along the section due to bending, or flexure formula. In bending about the z-axis, the normal stress, that is, the stress in the x direction, is equal to the acting moment about the z-axis multiplied by the perpendicular distance, that is, the distance in the y direction, divided by the moment of inertia about the z-axis. As mentioned previously, and by examining the equation, the maximum stress occurs in the fiber farthest from the bending axis, denoted in this case as y max. From the definition of the elastic section modulus, the flexure formula reduces to this expression. Substituting the known values and solving for m, the maximum moment about the z-axis is computed. Similarly, the maximum moment about the y-axis is computed. Notice that the maximum moment about the z-axis is about 3 times higher than the maximum moment about the y-axis. Check our Instagram account for more content and don't forget to subscribe to our YouTube channel. Contact us if you need free help in these topics. See you soon.